Hi, this is Sarah Parker, and I'm going to be doing a code explanation for assignment 9 of CPSC5010. The first question was related to writing a program that uses inheritance of a virtual class. So it asked us to write a program with student as the abstract class and then derive classes of engineering, medicine, and science from the base class. Then we were to create objects of the derived classes and process them and access them using an array of pointer of the type base class student. So first thing we did is created our virtual class in student. So for protected, which means our derived classes can access it but nothing else, we have our name, our age, and our major. And public is going to be using our constructor, and so we're going to assign name to name, age to age, and major to major. And then we have a virtual function called display. It's purely virtual, which means each derived class will have to implement that separately. And then we also have our destructor. So going on to our first derived class, engineering, it is derived from public, so we did include, or derived from student, and we included student.cpp up in our pre-processing directives. So for our engineering, we still need name, age, major, and we're going to assign that to the same thing for student. And then here's where we're going to be using our virtual display function that we have to implement. So for this, I just chose to do the engineering student, the name, their age, and their major. Very straightforward. Essentially, we're doing the exact same thing in every other derived class. So name, age, major will still be assigned to the variables in the student, and then we will have our display to override that since it's a virtual function. Same thing for medicine. I created a separate program to test all of this, so we included all of our files so it can access it. And this is where we were asked to create a pointer of arrays. So we're going to call student, and then we're going to make this dynamic. Sorry, it's not dynamic. We're actually making this fixed, and it's going to be size 3, just to make this straightforward. So for students at 0, our first object, we're going to make it in engineering. So we're calling our engineering object, and we're adding our name, our age, and what the major is. Then for our second object of students, it's going to be a medicine object, derived class medicine. And the name is Avery, the age is 21, and they are a medicine major. Same thing for our third student. They're going to be science, so we're just calling each of these derived classes to create that object underneath students. And she's going to be a biology major. So in order to access this information and print it out, we're just going to be using a simple for loop, and we're going to loop through each of the objects that we have created, and then we're going to call that display function that we had. After we display it, we're going to delete it so we free up our memory so we don't end up with a stack overflow. I've already compiled it and I ran it, but we'll go ahead and just show that program. And you can see our student information, that's this part right here. And then our engineering student that we created is here, and that shows up here. Ooh, that's kind of weird. And then the same thing for our other 2 majors. So that is how you create a virtual abstract class of student and then implement it with different derived classes. And then you can create an array of those students by calling each of the derived classes as well. So that was question 1. Question 2 was to implement a calculator using a class template program to add, subtract, multiply, and divide 2 numbers using a class template. And the reason you would want to use a template class for this is in case you were using integers for one, floats for another, doubles for another. You don't have to specify that when you're making your class. You can assign that separately. So let me pull this up. Let me close all these out so it's not taking up space. All right, so fraction. Nope, sorry, calculator. Here we go. Okay, so this is our calculator. So here is where we're using our template, class T, and that class will get used later to specify what type of data we want, whether it's integer, float, or etc. So our calculator class is going to have type T, which we don't know what that is until we call it, number 1, number 2. And then this is our constructor, so template number 1, number 2 is going to assign that to our private variables. And then all we have to do is just create our functions. So this is our add function, which will add number 1, number 2, and then return that number. And then same thing with subtract number 1 minus number 2. You can multiply the numbers, and then you can divide the numbers. This is to make sure that we don't divide by 0, because that will result in an error. If that occurs, then we are actually just going to say there's an error, there was a division by 0. So that's ensuring that our denominator is not 0. And to test it, the first thing is we're going to calculate it for an object of integers. So calculator int, this is where we specify what type it's going to be. And we're calling numbers 2 and 1. And then we're calling all of the functions that we have created on those two numbers. And then the same thing, we're going to test it to make sure that it works for a float. And I just did 2.4 and 1.2. And then we're going to subtract and add, multiply, divide, and see what we get there. So to run this, I'm pretty sure I've compiled it. And running it. Okay, and you can see that for our first one, addition is 3, 2 plus 1 is 3, that's good. Subtraction is 1, 2 minus 1 is 1. Product is 2, 2 times 1 is 2, and divide is 2 as well. 2 divided by 1 is 1. And then we have the same thing for our floats. If you add them together, you get 3.6. If you subtract them, it's 1.2. The product is 2.88, and division is exactly 2. So that is how you would make a template class when you don't know, or maybe you do know that you're going to be using different data types, but the functions are going to be the same. So very useful when you're working with different data types. Okay, and then the last one, we were asked to read a code about overloading an operator, and then to implement the overload for the operator plus and minus. So this is pretty cool in C++. Let's just close this. No, we want fraction. Yes. Okay, so you can actually overload the different operators. It doesn't change what they normally do, but you can add additional assignments to them. So you can overload this operator, you can overload the plus operator, you can overload the minus operator, so that it will accommodate different things like string concatenation and things like that. So this one we're using specifically for fractions. So most of this code was already written, but we'll walk through it anyway. So this is our constructor. Well, let's start back up at the top. We have a numerator and a denominator that are integers. And then we have our default constructor, which is a numerator of 0 and a denominator of 1. And we're going to assign that to the numerator and the denominator. And we're going to ensure that the denominator does not equal 0. So it has to not equal 0 in order for this class to work. And then we're going to create a copy constructor. So here we're calling our fraction class again, and we're making it by reference and we're calling it copy. So now we're calling the copy numerator and assigning it to the numerator, and the copy denominator to the denominator. Just to show when it's used, we're going to output to the terminal that the copy constructor was used. So this is the first overloaded assignment for equals. We're going to overload fraction by calling it by reference, and we're going to make sure that it's not the same thing. As long as it's not, then we're going to call fraction right here we're going to call the numerator, excuse me, for that, and the denominator, and assign it to the numerator and denominator. And we're going to return that as the pointer, as the object for fraction. So here's where we overloaded the plus and the minus. This is what we were actually asked to do. So again, we're calling our constructor, and we're going to pass that by reference. And then we're going to assign the new numerator. So here we're going to add whatever numerator we have, times our denominator plus our denominator times our other numerator. So here we're calling whatever object we have, and then we're doing a copy, and then we're also adding that together. So numerator times the other denominator, so that way we can add them together. And then same thing for our second one. And then we're going to return our object of new numerator and new denominator, which is this and this. So after we've completed these, then we're going to return that. Then we're going to do the same thing for minus. So this is our calculation to subtract one fraction from another. And so we do that by multiplying the numerator times our other, the copy constructor that we're calling, times the denominator by our denominator times our new numerator. And then we're going to get our new denominator by multiplying the denominators together. We're returning our fraction of new numerator and new denominator, again, here and here. So now, this was just an overloading for our output operator, and we're calling that by calling the reference to the out, and then our fraction, a reference to our fraction class. And then we're returning our numerator over our denominator. So calling our fraction class and then putting that out here. So the first thing that we wanted to show was that if we call the fraction class and we create that object of 5/3, this is our numerator, this is our denominator. We create a second class of our fraction, or a second object of our fraction class called f, and we're naming that f. We're assigning f to 5/3. This is our copy assignment, and this is where our copy constructor comes into play. So our C out is going to call fraction, and it's going to call f, and that should show that that 5/3, because that's our copy assignment. And then to validate how we have overloaded these operators, we're going to create two fractions. So fraction A is 1 and 2, that's our numerator denominator, and then fraction B is 1 and 3, which is a numerator of 1 and a denominator of 3. So instead of having to call multiple functions, because we've overloaded this operator, we can just say we want to add A plus B, and because we've overloaded this for integers, and these are integers, it will come here and it knows how to create a new fraction by adding the two fractions that we have specified here. So it's significantly more simple when you're actually outputting, because you do not have to call multiple functions. You are literally just telling the compiler to add A and B, and because we've overloaded it up here, it can do that. Same thing for subtraction as well. So let's get out of here and oops. Okay, let's compile that, and then we're going to run it, and we should see fraction 5/3 should be the first thing, and then the addition of 1/2 plus 1/3, which should be 5/6, and the subtraction of 1/2 minus 1/3, which should be 1/6. So we'll see. Okay, so here we have our fraction 5/3, and that is correct. We just called f here, and that overloaded our assignment as well to make that 5/3. That's what we did here. And then addition is 5/6, so that's just simply calling A plus B. We do not have to call any additional functions for it to add a plus b. And then the same thing for subtraction, a minus b, that is all we had to say. And our compiler did the rest, which gave us the 1/6 answer. And so that was implementing these lines of code and returning a new fraction. And that's that. So that is how you overload an operator and how it can make your code much easier to read. And it would be much easier for somebody else who did not understand to figure out what was going on here by just overloading the operators. So anyway, that is the 3 questions for assignment 9. I thank you very much.